All right, we're going to pick up for part 2 of working out all the solutions. We're going to start on number 16. Now, again, there is no reason to feverishly write down everything I'm doing. This is more for you guys to be like, oh, okay, good. I remember how to do this. Jog your memory. If you want to rewatch the videos tonight, over the weekend, work out the review, that sort of a thing. But if you don't catch everything the first time I'm doing it, I want you to pay attention so you see what to do and remember how to do it. That's the most important thing right now. For number 16, it says use the given zeros to find all the zeros of the function. All right, here's the function, the polynomial function. How many answers, how many zeros should I have for number 16? 4. It's the highest exponent. They gave me one over here. They said that x equals negative 3i. If they told me x equals negative 3i, they also told me that x equals what? X equals positive 3i. Remember, when they give you a zero that is an imaginary, you have to account for the conjugate. So what you do in a case like this is we're going to multiply these two together. When I move negative 3i over, it becomes plus 3i. When I move positive 3i over, it becomes negative 3i. Now we're going to multiply. So x times x is x squared. X and negative 3i is negative 3xi plus 3xi. And then negative 9i squared. As soon as you guys see I squared, what do? Cross it off. Change the sign in front. So what happens with my 3xi's? They cancel. So I'm left with x squared plus 9. Okay? Does anybody remember what we do with that? We're going to use long division. Good. I'm going to say x squared plus 0x plus 9. I'm going to divide that into 2x to the 4th plus x cubed plus 15x squared plus 9x minus 27. Now on your test, if it says use long division, all right, and you can use synthetic division because it's a multiple choice, then do that. Just because there is no x value, so I just put a 0 as a placeholder. So now, guys, we're going to go first term into first term. X squared times what gives me 2x to the 4th? 2x squared, yeah? So I'm going to put it right here above my x squareds. I'm going to get my subtraction ready before I multiply. So 2x squared and x squared is 2x to the 4th. 2x squared times 0 is, we're just going to be 0 here. And then 2x squared plus times 9 is plus 18. X squared. Good question. Where'd you get that 0 from? You have to have a placeholder since there isn't one. So before we subtract, guys, what do I need to do? I got to change all the signs. Distribute, distribute, distribute. So I have 15 minus 18 is going to give me negative 3x squared. I have a positive x cubed, and my x to the 4th cancel, correct? And then we bring down our 9x. Now we say first term into first term. So x squared times what gives me x cubed? X, positive, good. So go ahead and get your subtraction ready. X times x squared is x cubed. X times 0 is just going to give me 0. And then x times 9 is plus 9x. Before we subtract, what do? Change all the signs. We're going to distribute, distribute, distribute. So negative 9 and negative 9 is negative 18x. Then I have my negative 3x squared here, and your x cubes cancel, and bring down your minus 27. So again, last thing, we're going to go first term into first term. Negative, or x squared into negative 3x squared. Negative 3. Okay, get your subtraction set up. Negative 3 times x squared is negative 3x squared. Then I have negative 3 and 0 is going to give me what? Wait a second. Hold on. This was a positive right here, wasn't it? Yeah, so this should cancel. That's what I thought. Okay, yeah. So then I have my 27, right? So negative 3 and 9 is negative 27. So you don't have a remainder. When you do these problems, you shouldn't get a remainder. If you did something wrong in your math up there. But what do we do with what's left over? What do I do with 2x squared plus x minus 3? We factor it. What's going to happen is you're going to be given you'll be given the imaginary zeros, and then when you use your long division and go back, you'll be able to find the real ones. So when we factor this, what are the factors of negative 6 that multiply to give me a negative 6 but add to give me a positive 1? So plus 3x minus 2. And since my a term is not 1, I divide both by 2, right? So this is 2x plus 3 equals 0, and x minus 1 equals 0. So my other zeros are at x equals negative 3 over 2, and at x equals 1. I have 1, 2 zeros here, and 3, 4 there. So in a question like that, you'll be given the imaginary ones, then you'll have to find the real ones. You guys want to do another long division? You want me to do 17? Okay. What's up, Gabe?
I just used synthetic division for 16.
Okay. Did it work?
Yeah.
Okay. The only reason you can't do that is if it's a free response and it says use long division. But if it's a multiple choice, do whatever you need to. That's smart. It saves time. All right. So let's long division here. We have a trinomial on the outside, x squared minus 5x minus 1, and then on the inside, 5x cubed minus 21x squared minus 25x minus 4. Do you have any holes? Do you have any places where exponents are not accounted for? No. So we're okay here. We can just go ahead and start. First term into first term. X squared times what gives you 5x cubed? 5x. I'm going to put it up here right above my 25x. Just like to keep my exponents the same. So 5 times x squared is 5x cubed. 5 times negative 5x is negative 25x squared. And 5 times negative 1 is minus 5x. So we're going to distribute, 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 distribute. I have negative 25 and a positive 5 gives me what? Negative 20x, good. Negative 21x squared and a 25x squared is going to give me 4x squared, is good. And then I bring down my minus 4. So first term into first term. X squared times what gives me 4x squared? 4, right? Okay, get this all set up. 4 times x squared is 4x squared. 4 times negative 5 is minus 20x. 4 times negative 1 is negative 4. And then what do I do with all my signs? I have to change them. I'm going to distribute, 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 distribute. And what do you see happens? Everything cancels out. So what do you have left over? 5x plus 4. That's it. No remainder. If you had one, you would put it over the x squared minus 5x minus 1. Guys, what do they mean when they say remainder theorem? It's the only thing we care about, the remainder. They're giving me the value they want me to use with synthetic division, negative 6, up here in the corner. Now, I read out the coefficients of all of my exponents. So 2, 11, negative 21, negative 90, right? Yeah? You guys are going to be allowed to use a calculator. So 2 times negative 6 is negative 12. 11 and negative 12 is what? Negative 1. Negative 1 and negative 6 is 6, good. Negative 21 and 6 is negative 15, right? Negative 15 and negative 6 is 90. What is your remainder here? 0. That is a fine answer. F of negative 6 equals 0. What does that tell you if your remainder is 0? It's a factor. If that question was asking for factors or whatever, you would say, oh, x minus 6 is a factor. And then what would we do with what's left over? We would try and factor it. God bless. All right, 19. Show that x is a solution. Show that x is a solution. That's another way of saying, hey, take this number that I gave you, use synthetic division, and show me that x is an answer. How do I show you that x is an answer? What's your remainder going to be? 0. All right, so 1 times 3 is 3. Negative 1 and 3 is 2. 2 times 3 is 6. Negative 9 and 6 is negative 3. Negative 3 and positive 3 is... Okay, it should be a positive 9 here. Change this. This should be positive. positive on that I have in my hand, but not on our sheet. So, all right, if we make that little change, then this works, right? -3 and +3 is -9. Then this is a 0. So the rest of the question says, all right, we showed. How did we show that this was a solution? Because your remainder was 0. Then it says list all the real solutions. So one of my solutions I know is x equals 3. How do I find out what the other ones are? X squared plus 2x minus 3 equals 0. Can we factor this more? Yep, we sure can. So I have x plus 3 and x minus 1. Okay, so my other two x's are x equals -3 and x equals +1. You guys with me on that? Okay, good. Good. Scooting along. Given that x minus 4 and x minus 3 are roots, what are the other answers? Fully factored form, all right? What do you know by saying that x minus 4 is a factor and x minus 3 is a factor? 4. Good, guys. X equals 4 and x equals 3. If you know that both of those are quote-unquote answers, how could you figure out what the last one is? Can you use synthetic division? What could you use to synthetically divide? You could use 4 or what? 3, either one. Because you know two of them. I'm going to go ahead and just use 4. So I'm going to write out my coefficients. 1, -5, -2, and 24. So bring down 1. 1 times 4 is 4. -5 and 4 is -1. -1 and 4 is -4. -2 and -4 is -6. -6 and 4 is -24. And my remainder is 0, which we already knew. So now what do I do with what's left over? X squared minus x minus 6 equals 0. Can I factor that? What are my factors going to be? X minus 3 and x plus 2. So I found out that x equals 3, which we already knew. What is the last one that we didn't know? X equals -2. Good. Good. All right, describing the transformations. Whew, this should go quickly, guys. What does this negative right out in front mean? Reflect where? Good, over x. What is this 3, this number that is greater than 1 out in front? It's a vertical stretch. What is this plus or -1 out here at the back? Down. Good, 1. And then what does +4 inside mean? Left 4. Good. Remember, anything inside of a parenthesis is the opposite of what we think.
How do you know it's going to be a reflection over the x or the y?
If it's inside, it's a reflection over y. If it's out in front, it's a reflection over x. Yep. Good. All right, scooting along. Write each equation in its equivalent form, okay? That means if it starts off in exponential, we need to write it in log. And if it starts off in log, we need to write it in exponential, okay? Just go back and forth, good. How would I rewrite this? What does the big base become? The little number, right? And then what happens with 64 and 3? They switch spots, all right? All you're doing is just rearranging. You're just rearranging. What does the big base become? The little number. And then what happens with 1 over 25 and -3? They switch spots. Now, you'll have a calculator on your test, but they're not looking for the answer to this, right? They've already given the answer. They're looking for you to go from one form to another, but you can check. You can plug in what you put in your calculator. Like, you can plug in what you write down and see if it mathematically makes sense. What about this one? We're starting off in log, so we're going to what form? Exponential. So the little log becomes what? The big base, and then what happens with 64 and 3? They switch. Now, what I'm saying to you guys is just say, you were like, oh, I don't remember, and you wrote 3 to the 4th equals 64. You can check that in your calculator. If you put in 3 to the 4th, it's not going to equal 64. So then you go, oh, wait a second, I wrote it the wrong way or something. So yes, you are going to have a calculator, and yes, you can check, but if you're going from one form to another, I'm not looking for the exact answer. I'm looking for you to rewrite the equation. It's just missing a number. We'll just put an X there. All right, what happens now? Little log becomes, right, the big base, and then what happens with 3 and X? They switch spots. If I asked you what does X equal, you would tell me. How much? What's 5 cubed? 125. Good. All right, good. All right, if you guys are going to graph, remember, I'm going to go through this very quickly. You guys are going to have what? What are you going to have on your test? What are you going to have on your desk that you're going to be able to use? A calculator. So just make a table of values for something like this. Maybe 2 negatives, -2, -1, 0, 1, and 2. Plug it in, graph it. Yeah? You should be able to tell yourself, to make sure that you plug things in the calculator right, what should this graph do? What is this going to do right here? It's going to reflect where? This is going to go over the X, and where is it going to move? Up 2, all right? So in your mind, before you do this problem, you should kind of say, okay, it's going to flip over the X, and it's going to move up 2. Then just use your calculator, plug in a table of values, you're good to go. All right, 24, determine the zeros. Oh, man, I forgot how to do this. Do you guys remember? Yep. Again, this is that 2.6, that cheat sheet. How do you find the zeros? You set something equal to 0. Not the bottom. Numerator equal to 0 to find the zeros. So you'd say 2x squared equals 0. Divide by 2. X squared equals 0. Take the square root, right? What does x equal? X equals 0. If you guys were going to find the domain or the vertical asymptotes, what do you set equal to 0? The denominator. How do you find the the horizontal asymptote? What do we do for that? You look at the x, which you compare, numerator to denominator. Good. All right, write the quotient in standard form. What cannot be in your denominator when you have a problem like this? You can't have imaginaries. So we got to get that imaginary out of the denominator. The first thing I would do is I would rewrite my denominator in standard form. I'd say 3 plus 3i. That's step number 1. Step number 2 would be, okay, wait, what do I do again to get the denominator with no i's? You multiply by the what? I understand what you're saying. Not reciprocal, but we call it the conjugate. Remember, what's the conjugate of the denominator? 3 minus 3i. 3 minus 3i. Now, the first thing I would do is go ahead and simplify your denominator to make sure the i's cancel out. So what's 3 times 3? 9. 3 times negative 3i is minus 9i. 3i times 3 is plus 9i. 3i and 3i is minus 9i squared. What happens when you have I squared? Cross this out, change that sign. So guys, now watch what happens. If I have a positive 9 here and a positive 9 here, what's my new denominator? 18. What happens with negative 9i and positive 9i? They cancel. Did you get your i's out of the denominator? Yes. So now we just go ahead and simplify the numerator. Let's just multiply. What is 5 times 3? 15. 5 times negative 3i minus 15i. Negative 4i and 3 minus 12i. Negative 4i negative 3i is plus 12i squared. What do I do with that I squared? Cross it off. Make this a negative. So now real with real. What is 15 minus 12? 3. And then what's negative 15 and a negative 12? I. Negative 27i. Free response question. You'd have to simplify. You might get a multiple choice where you get this as the answer and you don't see it because it is simplified. So just make sure you guys understand what an unsimplified version would look like and a simplified if it's multiple choice. I would pull this apart and say 3 over 18 minus 27i over 18 and simplify independently. 3 goes into 3 once, 3 goes into 18 6 times. 3 goes into 27 9, and 3 goes into 18 6 times. Do they both have the same denominator? Yes, but can you simplify the one on the right a little more? Yeah, I can say 3 goes into 6 2 times, and 3 goes into 9 3 times, right? So this would be 1 over 6 minus 3i over 2. Multiple choice can be in simplified version or unsimplified version. So make sure you guys understand you can match your answer to a multiple choice answer if it's simplified or not. That make sense? Okay. We're moving along good. Yeah. All right, what does this mean? I have to FOIL it. I have how many 7 minus 5 i's? 7 minus 5i, 7 minus 5i. We're going to FOIL. Are my i's going to cancel out? No. Why are they not? Because the signs are the same. Good. So 7 times 7 is 49. 7 and negative 5 is negative 35i. Negative 5i and 7 is negative 35i. Negative 5i is plus 25i squared. Two things to clean it up. Number one is I squared becomes negative 1. So I have 49 minus 25, which is 24. And then what happens with negative 35i and negative 35i? Negative 70i. Just combine. All right, 27. Let's try to get to 32 for today. Solve. This was our chapter 3. 3.3 and 3.4. If we're going to solve. What kind of a problem is this? This is what kind of a problem? This is an exponential, yeah? What is the opposite of exponential? Log. All right, so I have to, there's nothing being added, subtracted, multiplied, or divided to this. So I have to figure this out using logs. So I'm going to say log, what's the little base that I'm going to use to undo this problem? 5. Yep, whatever the big base is, that's your little number. What you do to one side, guys, you do where? Good, so log 5 is 6. So on the left-hand side, what happens with log 5 of 5? It cancels, so I have 3x equals... Anybody remember how to do this in your calculator? It's going to be log of the visually bigger number divided by log of the visually smaller number. Can someone do that in your calculator, please? Okay, so we got 3x equals 1.112. And then what do we do to both sides? Divide by 3. So what'd you get, babe? 0.371. Okay, perfect. What can I do with that answer? What can I do with that answer to see if I'm right? You can plug it back in. Just plug it back in. Use your calculator, plug it back in. All right, now we're going to find the x-intercepts. X-intercepts. Anybody remember how to do this? To find an x-intercept, you plug in 0 where? For the y, okay? So if I plug 0 in here, this says ln of x minus 7 equals 0. Okay, exactly what we just did, guys. What is the opposite? What's the inverse of ln? E. So I'm going to use e, and then everything goes in the exponent, right? What you do to one side, you do where? To the other. So e and ln cancel. You have x minus 7 equals, what is e to the 0 power? 1. I'm going to add 7. So what does x equal? Perfect. Same thing over here. I'm going to plug in 0 for y. So I have log little 2, x minus 2 equals 0. I'm starting off with a logarithmic function. What's the opposite of logarithmic? Exponential. So the little number is 2. That means I'm going to use a big 2. Then everything goes in the exponent. And what you do to one side, you do where? So I'm going to write a big 2 and then a 0. So 2 log 2 cancels. I have x minus 2 equals, what's 2 to the 0 power?
1.
Perfect. Add 2 to both sides, so x equals 3. God bless.
Can't you just make it 1?
Yeah, I'm just showing you why you can just make it 1. Oh, geez. One of these log ones again. What do you guys notice about this? It's the one log on the left and one log on the right, and they're exactly the same. So what can we do? You could just cancel them. Perfect. So 5x minus 7 equals 2x plus 5. Move every x to one side, move the numbers to the other. So I'm going to subtract 2x, and then I'm going to add 7. So 3x equals 12, x equals 4. What do I need to do with 4 to make sure that that is a valid solution?
Make sure
I have to plug it in, but make sure what, Soph?
that you don't get 0 in your parentheses.
Not 0. You don't want what kind of a number? Negative. I have to make sure that that, God bless you, number that I get does not make my parenthesis negative. If I plug 4 in, what's 5 times 4? 20 minus 7, we're good, right? On the other side, 2 times 4 is 8 plus 5, we're good? All right, your valid answer. You just cannot take the log or the natural log of a negative number. Ooh, find the domain in vertical asymptote. Kind of remember doing this, 3.1, 3.2. When I have a log, what do I do to find the domain in the vertical asymptote? 3, 1, 3, 2. I set the parenthesis, what? Equal to 0. That's it. So subtract 3 from both sides, so x equals negative 3. That's your vertical asymptote. That's the line that your graph's going to get really, really close to, but not touch. So think about it. Is this domain going to be negative infinity to negative 3 or negative 3 to infinity? This one, yep, negative 3 to infinity because it's a positive. If it was negative, it'd be the opposite. Good. That's 3, 1, 3, 2, guys. Yep.
What do you mean if it was positive? Like if the log?
If this right here was negative, it'd be the other way around. It'd be negative infinity to negative 3. Everybody right now, what's the answer to 31? Come on. Everybody? 1. Log 9 of 9 cancels. All right, that was chapter 3. What chapter are we moving on to now? 4. Guys, this should be pretty quick. All right, you have a calculator you'll be able to use, but we need to remember how to do this. How do you convert from degrees to radians, radians to degrees? Pi over 180 or 180 over pi. How do you know what goes where? Whatever you want to cancel. I want degrees to cancel out, so degrees is going to go on the bottom. However you guys want to do this. You want to multiply across, then simplify, whatever. But what goes into both 180 and 225? Okay, 5. Tell me what it is. Is this 45 and 36? Right? Wait, hold on. 36, 45. Okay. What? Anything else? 9. Okay, 9 will go in here. So negative 5. 9 will go in here 4. So negative 5 pi over 4. Simple enough. Very easy conversion. If we're going to convert to degrees, what's going to go on the bottom? Good. So pi's will cancel. 6 goes into 6 once. How many times is 6 going to 180? 30. And then what's 30 times 11? 330 degrees. Good. Ooh, how do we find one positive and one negative coterminal? You're going to add and subtract 360 or 2 pi. Good. So I'm going to take my angle, negative 125, and I'm going to add 360 to it. What is negative 125 plus 360? Negative 125 plus 360. How much? 235 degrees. Okay. Is that a positive coterminal? All right. You're good to go. A negative 1 would be negative 125 minus 360. What is that going to give me? Negative 125 minus 360. Negative 485. Are those the only two answers that are valid? No. You can keep adding 360 and keep subtracting to get coterminal. So if it's a free response, you can add a couple times if you want to. If your multiple choice answer doesn't appear, add and subtract 360 again and see if you found something. Maybe they used a different, they added 720 or something. 11 pi, I'm going to add 2 pi. So when I do that, I get a common denominator. Do you guys agree with me? This becomes 14 over 7. So 11 and 14 is, so 25 pi over 7. Is that a positive coterminal? Yes. So I'm going to take 11 pi over 7, and I'm going to subtract 14 pi over 7, which gives me negative 3 pi over 7. Is that a negative one? Okay, good to go. If I subtract and my number is still positive, what do I do? Just subtract again. Good. Okay, guys, I'm going to stop there for part 2. I will upload this in a bit, and then tomorrow I will finish up. This is I period, so you guys have an extra review day. So make sure you're watching everything over the weekend. Come in next week and ask questions.